Okay, so let's look here, zoom it in, number 4. It's already in standard form. Great, that's the more difficult one sometimes because it takes a long time. So now I need to factor it. So that reminds me of x squared minus 6x plus 9. And if I factor that, two numbers that multiply to get 9 and add to 6 are 3 and 3. If I have the same number, okay, I need to write it, okay, well that's really squared, but it's the same thing twice. So it's really f of x equals x squared minus 3 squared, because there's two of them. Will I mark it wrong? Yes, you'll lose a point. The x-intercepts, okay, well if I have x squared minus 3, and I set it equal to 0, add 3, x squared equals 3, square root, square root. So x equals plus or minus rad 3, but this one is also x squared minus 3. So really the roots are plus or minus rad 3 multiplicity 2, because I have two answers here and two answers there. So the intercepts would be rad 3 comma 0 and negative rad 3 comma 0. I don't need you to write that two more times. You stated it there. The y-intercept 0, 9. Okay. Before I can do anything else, I have to graph it. So I'm going to graph it. Rad 3, it doesn't matter where you put it, it's fake. Negative rad 3, and the y-intercept is 9. Okay, x to the 4th. If it's x to the 4th, it starts on the top. What I have to remember, though, is that since it is multiplicity 2, it's going to be a bounce. So it's going to bounce here, and it's going to bounce there. So I start here, and I bounce, and I bounce. We don't all have to have the exact same graph, but it should be pretty close. Then this is negative infinity, positive infinity. This would be 0, 9. This would be positive infinity, because they're both going up. This is negative rad 3 comma 0, rad 3 comma 0. I need to state all the points where it changes. Okay, min and max. All right, so let's see. The max, there is no max, positive infinity, but there's a relative minimum or maximum of 0, 9. The minimum, there is a minimum. There is a lowest point. There's two lowest points. But if you were thinking about you could only pick one, what would you pick? The negative minimum or the positive? The negative, because it's smaller. So my minimum is negative rad 3 comma 0. My domain means everything to the right, everything to the left, all real numbers, negative infinity, positive infinity. My range is everything up, everything down. It's only up, greater than. Now, the value, remember when we said it was the y value of the vertex? Well, if you look, in a sense, those are both vertices. So there's 0. And that means 0 comma positive infinity, parentheses. Intervals where it's increasing and decreasing. Okay? So from here to here, decreasing. From here to here, increasing. From here to here, decreasing. Oops. From here to here, increasing. Okay, sorry, it's getting uglier and uglier. As x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. So, it's the y value. When it's negative, it's positive. When it's positive, it's positive. Okay? And with that being said, I can go to the next page, number 5. All right. Factored form or standard form, it's there. You can't do that on the test. You have to rewrite it. So if I'm going to put it in factored form, I better factor it. They are all even, so they all divide by 2. But since that's negative, I'm going to divide it by negative 2. I also notice they both have 2x squareds. So I'm going to divide it by negative 2x squared. If you get stuck, the easiest way would be to do this. Divide negative 2x squared. Divide negative 2x squared. Divide negative 2x squared. Divide negative 2x squared. So that would be x cubed minus 3x squared plus 4x minus 12. Okay? So I get x cubed minus 3x squared plus 4x minus 12. And it's a little bit messy, so let me make it here, okay? Now, if it has to be in factored form, it is not completely factored. If I cover that up, this is factored by grouping. 2 of those, 2 of those. Pretend that's not even there. X squared, x minus 3, 4x minus 3. Now it's x squared plus 4, x minus 3. Now, negative 2x cubed. That is the answer in factored form. Okay? Now some of you go, can't you keep going? You can keep going if it said x squared minus 4, x minus 3. Then you could go x minus 2, x plus 2, x minus 3. Because it's called the difference of squares. But when it's the sum of squares, you can't factor it. There is no such thing. Okay? So now the x-intercepts. All right. So if I'm going to focus on the x-intercepts, there's a 0, multiplicity 3, because there's 3 of them, 3, and I have to solve this one. So if I set that equal to 0, subtract 4, square root, plus or minus 2i. So plus or minus 2i. Let's make sure I'm good. I've got 2 answers there, 3 answers there. Wait, where did I make a mistake? Ooh, you guys saw that ahead of me. Look at me, I've had negative 2x squared and then I put 3. That's why it's always good to check. So that should be negative 2x squared, and that should be multiplicity 2. Now I have 2 answers, 3, 4, 5. Now I'm good. Write them as points, 0, 0, 3, 0, 2i, comma 0, negative 2i, comma 0. The y-intercept, well, there is no y-intercept. So it's 0, 0. I mean, there is a y-intercept, but it's at 0. There's no number there. Remember when I told you if the x-intercept is 0, then the y-intercept is 0? That's because if you graphed it, it crosses the x and it crosses the y. All right, I'm going to do my quick graph. Obviously not so quick. So 0, 3, okay? 2i and negative 2i. It's imaginary. There's nothing there. The y-intercept's already covered. So when it's to the 5th power, you start from the bottom. But since it's negative, you start from the top. Okay? There's a bunch of different ways to do this. Okay? But since it's multiplicity 2, I bounce. And then when it's a 3, I go through. But the problem is that's only 1, 2, 3, and it's x to the 5th. So then you got to go like this to account for a 4th and a 5th. Okay? All right. Your graph doesn't have to look exactly like mine. Your graph could have been, if this is the 0 and that's the 3, I could have gone like this. That could have worked too. Okay? There's different ways to go. So with that being said, this is up forever, negative infinity, positive infinity. This has got to be between, let's see, it bounces at 0, so this is 0, 0. This has got to be between 0 and 3, so we'll say 1, 7. I don't know. This has got to be after 3, so I'll say 4, negative 5. This has got to be after 4, so we'll say 6. But it's above my negative 5, so that would have to be negative 3, or negative 4, negative 2, or negative 1. Okay? The max, no max. Positive infinity, no min. Negative infinity. But I have a relative max that I stated was 1, 7, and I have a relative min that I stated at 4, negative 5. Domain, all real numbers, negative infinity, positive infinity, all real numbers, negative infinity, positive infinity. Okay? Intervals increasing and decreasing. Okay. Negative infinity, 0, 0, 1. 1, 4, 4, 6. Let's see. 1, 2, 3, 4. Oops. I didn't do the last one because there's got to be 5. Positive infinity, negative infinity. That's what happens when we go too fast. So now 6, positive infinity. It's to the fifth power, 1, 2, 3, 4, 5. Okay? As x approaches positive infinity, f of x approaches, da 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 da. When it's on the negative side, it's positive. When it's on the positive side, it's negative. And you're going to write it out. All right, last one. This one is in factored form. Yay, I don't have to factor. But then what I'm going to have to do is box it out. So I'm going to take this, and I'm going to write it 2 times. And I'm going to box it out. x4, x4. X squared, 4x, 4x, 16. These are the same. X squared plus 8x plus 16. Then I multiply it times 1/2 x. So I get y equals 1/2 x cubed plus 4x squared plus 8x. The x-intercepts, well, they were already done for me. That would be 0. And that would be -4. I can either say that it's a bounce here, or I can say it here. X equals 0 and -4, multiplicity 2. Okay? Y-intercept. Well, the y-intercept is the last number, but there's no last number.
Hello?
When the x is 0, that means the y is also going to be 0. Okay? All right, let's graph it. My important points are 0 and -4, and that's going to be a bounce. Okay, it's x to the third power, which means it starts from the bottom, but at the -4, I got a bounce. Let's fill it in. Negative infinity, it's going down. Positive infinity, it's also going up. This is the point -4, 0. This point has no meaning to me because it's the vertices that matter. It's the vertices. So I'll say -2, -3, and then I should be good. I'll do the intervals now because why not? Increasing. -4 to -2, decreasing. -2 to positive infinity, increasing. 1, 2, 3, it's cubic. End behavior as x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches negative infinity, positive infinity. Okay, domain, I like this one. All real numbers, negative infinity, positive infinity. Range, all real numbers, negative infinity, positive infinity. Now the maximum, there is no max, positive infinity. There is no min, negative infinity. But there's a relative max at -4, 0. And there's my relative min at -2, -3. Okay? So honestly, I bet with practice you'll get awesome at it.